Yeah, the fish meal dilemma. What are the alternatives? There may be many. The dilemma is that I should stand there. The wild catches now show negative trends, and implying reduced fish meal production. There is also more competition. Yeah, okay. If we look at the graph here, we see the development since 1950 to 2050. We see the wild captures have reached a plateau. This is a number that you can remember. It's in line with the numbers we have seen before, 90 million ton per year. But it's maybe that's what the ocean can produce, at least the way we catch the fish. Then the aquaculture has expanded, and the prognosis is that to fulfill the demands, we need to expand aquaculture. We cannot rely on captured fish for, at least not for fish meal production. So the numbers 60 and 70, you can keep in mind until the next slides. New nutrient sources are urgently needed if we are going to meet these demands. And yeah, let's just have a look at what kind of fish aquaculture we have. We have the carp. It's not eating fish meal at all, but that's a way dominating species in cultivation. We have the clams, tilapia, oysters, shrimp, catfish, the freshwater nai. I'm not sure what that is. We have the salmon, which we produce in Norway and think it's the world's biggest. It's not at all, but it eats a lot of fish meal, or used to. Mussels, scallop, pangasius, and others, many others. Okay? What has happened with the amount of fish meal in the diet for the different species? This is percentage, and here's the development over some years. You can see that the different species here, we all have experienced decrease in fish meal content in the diets. And for these species which had most fish meal, except the eel then, there has been a larger drop. If you look at the overall share of fish meal, in contrast to inclusion of oil seeds in the diets for salmon, you see this development. And for the shrimp, the figure is much the same. Let's just have a little look into the other productions that used to use fish meal. Pig, chicken, aquaculture, other, and see what has happened over the last, since 1960. This was the use of the fish meal. The total was 3 million ton per year, and the pig and the chicken took most. In the 1990s, this had changed a little bit. And, oh, sorry. Oops. Push it, no. Yeah, okay, here you see the picture. What happened? These days, aquaculture takes all. Whereas the chicken still, the pig still gets a little bit, and the chicken as well. For other purposes, we don't use fish meal anymore than before. And here is a graph that kind of just stressed the dilemma. Here is the fish meal production decreasing. It's not zero here, so it's not as steep as it can look here. And there are two prognoses for demand, a high and a low. And we are now in the situation where the demand cannot be met. So there is an urgent need. What can we do? Well, I think we have to look into all kinds of tools, and I will go through some. Although predicting the future is very difficult, but I will try to guess what can happen. We can, of course, make sure that the animals use the fish meal we have the best way, but then we need more accurate estimates of nutrient requirements. That will improve feed utilization and extend the fish meal we have, so we get more out of it. It may be time-consuming, expensive, and there are so many new species that come into it, but we should try to get to understand the nutrient requirements. They are not the same for all fish, not at all. We can also start include into our breeding programs more strength or power pressure on feed efficiency, on tolerance for new ingredients. It's obvious that the fish, it has been shown in rainbow trout that we can, after the 4th generation, feeding them soybean meal, which is not the best they can get. They tolerate certain soybean meal. The enteritis that we see in the intestine, when we feed soybean meal to both salmon and rainbow trout, it's no longer there. So I was really amazed. 4 generations, that's not much. And it was not really looking at or focusing on the enteritis, for example. It was just that they selected for those that grew best on the soybean meal, and they could tolerate it. And I'm sure with all the new ingredients that we are going to use, we will have to meet challenges which we can overcome by breeding. It's also time-consuming and expensive, but still 4 generations of salmon. Well, that's like 20 years, but we are looking way beyond that in our perspectives now. We can certainly improve our use of the available marine resources. They are the best. We have to say, admit that. The nutrient balance is perfect for our aquaculture. So we can improve use of harvested marine resources. And if we just look at the European example, what are we doing with our fish? Well, 45% is used for human consumption. We have onshore processing waste, 35%. Gutting waste, 5%. And discarded at sea, 17%. We should take care of all this that we are not using today. Some is already going into fish meal, but a lot is also lost. Certainly we can do better. We can improve the nutritional quality of fish meal. I think the fish meal producers should do a better job. If you go into the Feedipedia and look for digestibility values for energy and protein in the different fish meals. So here we have 2 different qualities, a high protein fish meal and a medium protein. And look at this is 2 times standard deviation. So this is the variation we find in fish meal, energy digestibility in fish meal. We should be here around 100. And that will give us a lot of more available fish meal, or we get more out of the fish meal. The protein variation seems smaller here, but I have seen number in my experiments that are down to 75% digestibility of protein, which is way too low. So if we can improve the processing of the fish meal, we can extend the use of it. We can put lower levels in the diet. So I think that's also an option. We can increase harvesting of underfished resources, and the krill and the colonus in the North Atlantic are underfished. But there are some challenges regarding the harvesting technology, processing technology, and also around food safety, because they deteriorate so quickly. Here we see the krill, which we harvest in the southern, around the South Pole. Huge amounts. The annual biomass is estimated to be 100 million tons. Catch quota is 5.6 million, but we are not harvesting more than 0.2 these days. The challenge is high chitin level, fluoride, copper, cadmium in the exoskeleton. The colonus, which we have a lot of in our waters, but they are much smaller than the krill. The krill is 0.5 centimeter. The colonus is smaller, so the technological challenges are more regarding the harvest. But the production is even higher than for krill, 200 to 350 million tons, and we harvest of as little as 1% would represent a valuable contribution. Nowadays we harvest lit for human medical purposes, but nothing else. It's too expensive. But the resources are there. We should look into that. Challenges for the colonists is about the same as for the krill. But then I think, at least in the near future, to be able to increase our aquaculture as we want, we are dependent on terrestrial resources. We can use our animal byproducts better. They have a suitable nutrient composition, but variable lipid quality. Some, for the salmon, for example, we cannot really use the pig and not at least the ruminant lipids, because the melting point is so high. But the chicken is easier, and we are talking about large amounts. 30 to 50% of animal food products are not consumed by humans. This means 50 to 100 million tons worldwide annually. It's a huge amount. Should be used, must be taken care of. Most is rendered to meat and bone meal, the poultry and feather meal, blood meal, etc. I won't list it. But in Europe, you had this BSE problem, the mad cow disease problem, which means that we don't use these resources. They are huge, and we don't use it, even though the ban on the use has been lifted for aquaculture, but people don't want it. The fish producers don't want it in the diet because they are afraid of the consumers' reactions. So huge resources are now just composted. It's really too bad. Then we can use plant ingredients, and the best option in the near future is then what we know. We can use the soya. We can use whole grains, particularly the glutens, which we get from starch production, or as a byproduct from starch production, or from the biofuel. I really hope in the future we'll not use food for biofuel, but it's really heartbreaking. But anyway, it's done, and it's not decreasing, I think. But we get the gluten out of that, which is now, so for salmon production, these glutens are highly valuable and used a lot. And because of salmon, then it's not so good to with soybean meal for them, then the gluten has helped the situation. Yeah, what is oil seeds? Yeah, it's soya. And then rapeseed, cotton, sunflower, groundnut. That's what we have. And soya is dominating so much. And here is the development and the forecast for the soya total oilseed production in volume and value. That's the forecast, so it's increasing. So we'll have resources available here. But on the longer terms, we shouldn't use these foods that can be eaten by humans for our animal production. So we should look for other resources. And what is needed? We need carbon. The nutrients contain carbon. Okay, carbon is, we have a lot of carbon in the atmosphere, in the vegetation, in the soils, marine biota, surface ocean, dissolved organic carbon, deep oceans, fossil. In Norway, we have a lot of methane gas. That's CO carbon. And we are talking about gigatons. So it shouldn't be a problem. We need oxygen. It's in the air. Nitrogen. It's in the air. We need energy. We have the sun, if we don't want to use fossil energy. We need the minerals. And among the minerals, there's a lot of minerals in our grounds. But the phosphate is a challenge, really a challenge. We have to deal with the phosphate problem. We can discuss whether worst case it's the mines are empty in 40 years or 100 years or 200 years, but even that is short sight, really, for the human population. But we have to deal with this, and we have to take, because it's an absolute element. It's there, but we just pollute the oceans with it. Maybe we can grow the seaweed so that we can get it back, but it's a very slow, and the circle gets so long. So it's not maybe not the most economical. We should take care. What are the possible sources of carbon if you focus on that? Yeah, wood. If we can use the wood for food production or for feed production, it would be great. There is so much wood, and if just focusing on wood waste, we are talking about enormous amounts. What is the composition of wood? Well, it's only 2% protein, 2% lipid, some ash, a lot of fiber, a lot of lignin, and some extractives. So not perfect for fish production. There's a huge amount of agricultural waste, which has about the same composition. A lot of carbon. We have the kelp. Huge amounts, as we heard. And this is the Palmaria palmata, beautiful kelp, which is caught in the Gulf of St. Lawrence. And it's believed to be the largest production of seaweed in the world, as I read from FAO. In Norway, we have mostly this Laminaria hyperborea, and they are growing in large amounts, not used. Well, we use the Laminaria for some alginate production, which costs some 1,000 crowns per kilo and used in medicine, but that's what we use it for so far. The composition, quite variable in protein, 5 to 30, some lipid, some ash, quite a bit in some, and then a lot of fiber that is not digestible. And it's not so easy to use. We can use them, these weeds, as vegetables, yes, but we don't get much, either protein or energy from it without processing. And processing is very expensive. So we need, but there are some, we can have some helpers here. So, and food waste. We are wasting so much food around the world, and it's piling up or polluting our waters. We have to stop. Roughly 1/3 of the food produced in the world is lost or wasted. And we're talking 13,000 million tons a year. If we can use this, there shouldn't be any problem. Yeah, and the industrialized countries and developing countries are as good in this or as bad. And there is 30% cereals, 40 to 50% root crops, fruits and vegetables, 20% of oilseeds, meat and dairy, 35% of fish, and these percentages are lost of the different foods. And composition has been, of course, it's very highly variable, but averages over 19 studies show 14% protein, 15% lipid, starch and sugars 43, ash 3, cellulose 8, and other 17. Yeah, maybe it's possible to use as a source. And we have the sewage. It's maybe you shouldn't mention this, but we are polluting a lot, or wasting a lot of carbon through our. So we just have to stop using flushing the toilet and then sending it out. We just have to stop that. This is what happens in the oceans, and we lose all this carbon, and we lose the phosphate. There's plenty of phosphate in this we should take care of. Yeah. Carbon, nitrogen, and phosphate is lost. So, and we in Norway have natural gas, and many other countries have lots of natural gas with methane. It's possible to use also for food production. Challenge with all these sources I've talked about lately is that the nitrogen to carbon ratio is not optimal. So we need some helpers, and to improve the balance, nitrogen carbon balance, and which are these helpers. We should use nature's own unique organisms that are available. For example, microorganisms such as bacteria, yeast, macroalgae. Here are some examples that are already in use. The Metylococcus capsulatus, which grows on methane. And we're talking about good protein levels that we need in aquaculture. Yeast, the Saccharomyces is grown. And again, we have a lot of protein and not too much fiber and other stuff we don't need. Microalgae, also good protein. And they can produce, like here, astaxanthin, which you also need. So these are the microorganisms. And then we get back to the insects, which we talked about earlier today, and earthworms. Examples that are already in use. We heard about the black soldier fly, and we are talking about high protein and lipid levels, almost perfect. And the mealworm, same. If we harvest them at the larva stage, like here and here, the efficiency of production is so high. And if we feed them to the fish, we cannot get animal foods produced more efficiently. But they all are per kilo terms, both the fish and there is no other animal production that can compete. So this is what we should do. Here is there's a lot of silk produced in the world, and the pupa, they are also 60% protein, 26% lipid. It's almost perfect. And what is the salmon? When we go fishing salmon, what are we using as bait? Flies, worms. That's what they want. We should use this. So the fish meal dilemma, there are reasons to be optimistic, I think. Great resources of available carbon, oxygen, and nitrogen are underused. However, we need the engineers to develop the technology that is needed. But in Norway, we produce from natural gas bacterial meal, but we need to build facilities like this. It costs, but if we need the food, we can afford to pay it, I'm sure, if we do things right. And we have to find means to recycle phosphate efficiently. We run out of phosphate. Yeah. We have to realize that the chemical composition of these new ingredients will not be optimal for the fish. Here I just show, oops, wrong. Oh, sorry. Yeah. Just shown a relative content of minerals in soybean meal compared to the needs of the salmon. And as the blue line is the 100% of the requirement of the salmon. And here you see the content of the minerals. They are way too low. So we need to balance that up. Maybe more difficult with those minerals that are higher, or the nutrients that you have too high levels of. What can we do? It's not so easy. But we will have to tailor-made supplements so that we can balance up to make sure that they get what they need. And we can have compounds helping us overcome low palatability, make nutrients more available, rectify nutrient imbalances, reduce impact of anti-nutrients, regulate gut microbiota, improve immune functions, improve gut health, because all this will be challenged when we use ingredients in the diets that are not natural for the fish. And present additives will find new applications, and new additives will be developed. So, and the list is already long, as you can see here. And I'm sure Biomine would like to take advantage of all these needs that will develop. And other dilemmas, as we have already touched upon, the oil seeds and grains, they are food for humans. Here, I'm pushing the wrong button all the time. Here you can see what I ate last week. I was on a discussion panel about eating insects. And this is what we ate. Can you see the crickets? Yeah. And they were good. They were roasted in some oil and a little bit of spices. and I ate one by one just to get the taste, and they were good, absolutely. So someone asked if anybody had eaten, and it was good. But we have to, so we shouldn't compete with humans for food, and aquaculture feed production should be based on the principles of circular economy and help push development in the right direction. They shouldn't, the present situation is that we take, we make, and we waste to a large extent. We have to come into a situation where there is no waste. We have to find ways to upgrade the waste so that someone wants to make money out of that. And so we have to go into a circular economy situation. I don't think the general public has realized, but a lot of work has been done in Canada, I know, and also Europe has some strategies that will help us in this direction. So, thank you.